Education. Education, baby. Come on. Education has no end. Education.
Hello students, welcome to our today's lesson on halogens. Halogens belong to a group that is found in the topic of chemical families. Welcome as we discuss together. Thank you. These are elements in group 7 of the periodic table. They include fluorine, chlorine, bromine, and iodine. Some of the physical properties of halogens can be summarized in the table below. We have fluorine. The chemical symbol of fluorine is F, capital F. The atomic number of fluorine is 9 and the electron arrangement is 2.7. Then we have it followed by chlorine. Chlorine has a chemical symbol of Cl, atomic number of 17, and an electron arrangement of 287. Then we go to bromine, which is following chlorine, with a symbol of Br, an atomic number of 35, electron arrangement of 18.7, and finally we have iodine, which has a chemical symbol of I, capital I, atomic number is 53, and the electron arrangement is 2, 8, 18, 18, then 7. Halogens are colored, and some halogens give distinct colors depending on their state. Therefore, halogens are colored substances, and they give distinct colors depending on their state, whether in the solid state, liquid state, or vapor state or gaseous state. Some adjectives like yellowish, reddish, and brownish should not be used to describe the color, but just say red, yellow, and brown. So avoid the ish at the end. For example, fluorine is a yellow gas. Chlorine is a green gas, or you can just say pale green gas. Bromine gas is brown. Iodine is a black solid. In the solution form, it is brown, and in the vapor form, it's purple. The color of halogens depends on the states below. Let's look at some of the states which describe the colors of halogens. Now, according to the table below, we have the physical properties of halogens, some of which we had learned earlier. For example, the halogen's name, the symbol, and the atomic number. Now we have additional physical properties such as atomic radius, ionic radius, melting point, boiling point, appearance at room temperature, and the electron affinity. Now let's go straight to the appearance at room temperature. Fluorine gas at room temperature is yellow in color. Chlorine is green in color. Bromine is a red liquid. And iodine is a black solid. So those are the physical colors while they are in the room temperature. When we talk about electron affinity, it is the ability to lose electrons, to gain electrons, the ability to gain electrons. So you can see the ability of fluorine to gain electrons is 322, followed by 349, 325, 295. So generally the electron affinity decreases down the group. Now, boiling points. The boiling point of fluorine is -188. of chlorine is negative 35, of bromine is 59, and of iodine is 184. So again, the boiling point increases down the group. The melting point for fluorine is negative 238, chlorine is negative 101, bromine is negative 7, and iodine is 114. Again, the melting point of halogens increases down the group. Ionic radius. The ionic radius also for fluorine is 0.136, chlorine is 0.181, bromine is 0.195, iodine is 0.218. Again, is it increasing or decreasing down the group? The ionic radius decreases down the group, and we shall look at the reasons why in the next discussion. Now, finally, the atomic radii. We have fluorine at 0.084, chlorine at 0.099, bromine at 0.114, iodine at 0.133. Again, the atomic radius increases down the group. So the rest we had talked about them. So let's go to the discussion as to why these physical properties behave the way they are behaving according to the table. Now, trends in physical properties. The atomic radius and ionic radius increase down the group. This is due to the increase in the number of occupied energy levels. So, we are getting the reason as to why the atomic and ionic radius are increasing down the group, and the reason is because there is an increase in the number of occupied energy levels as we move down the group. The atomic masses increase down the group. By the way, atomic masses are as a result of the neutrons and the protons which are found inside the nucleus. So, among the halogens, atomic masses increase down the group due to an increase in the number of protons and neutrons. So, as we go down the group, there is an increase in the number of protons and neutrons, and thus an increase in the atomic masses. Now, if we compare the ionic radius and the atomic radius, you realize that the ionic radius is greater than the atomic radius because halogens react by gaining electrons, which leads to an increase in the repulsive force, hence increase in ionic radius. So during the reaction of halogens, electrons are being attracted towards the halogen, yet there are more electrons in the energy levels which tend to repel the incoming electrons. Therefore, an ion of halogen will have a bigger ionic radius as compared to the atom. Now, the melting and boiling points increase down the group due to the increase in intermolecular forces of attraction between molecules with increase in size of the molecules. So, as we go down the group, there is an increase in the size of molecules. Now, this makes them have very stronger intermolecular forces of attraction between them because there are now very few spaces held between them. Therefore, the intermolecular forces of attraction are the ones that make the melting and boiling point increase down the group. Fluorine and chlorine are gases at room temperature. Bromine, a liquid, and iodine, a solid, due to the increase in the intermolecular forces of attraction between molecules, which increase with increase in the size of the molecules. As we've said up there, that as we go down the group, the molecules increase in size. So this one also affects the state of the element, that the first two are gases at room temperature, followed by a liquid, which is bromine. Then finally we have iodine, which is a solid. Therefore, this is as a result of the intermolecular forces of attraction between the molecules, which increase with increase in the size of the molecule. The electron affinity of halogens decreases down the group due to increase in atomic radius, and therefore reactivity decreases down the group. So that one we had said, the electron affinity of halogens decreases down the group due to the repulsive forces. As we go down the group, the number of electrons in the energy levels increases. Therefore, the repulsive forces increases down the group. Hence, the electron affinity decreases down the group. Now, let's look at the laboratory preparation of chlorine gas. Chlorine gas is prepared in the laboratory by the heating of concentrated hydrochloric acid with manganese 4 oxide. Concentrated hydrochloric acid is heated together with manganese 4 oxide to produce chlorine gas and other byproducts. Now, the setup for the laboratory preparation of chlorine gas is as follows. We have a source of heat and we have concentrated hydrochloric acid being dropped by a dropping funnel. Then we have manganese 4 oxide which is being heated. It can be manganese 4 oxide. It can be any other oxidizing agent like potassium permanganate and so on. Then when the gas is produced, it is passed through water. The water is meant to absorb any traces of hydrochloric acid that are present in the gas. Then from there, it is passed through concentrated sulfuric 6 acid. The role of the concentrated sulfuric 6 acid is to dry the gas. Then finally, it is collected by downwards delivery because it is dense than air. Now, the role of potassium permanganate or manganese 4 oxide or lead 2 oxide is to oxidize the hydrochloric acid to chlorine gas. So, they act as oxidizing agents. Now, that is the setup for the preparation of chlorine gas. Manganese 4 oxide plus hydrochloric acid is manganese chloride plus water plus chlorine gas. So, the other products which are produced together with chlorine gas are water and manganese chloride. Manganese 4 oxide is an oxidizing agent, and we can also use potassium permanganate or potassium manganate 7, but in that case, heating will not be needed because potassium manganate 7 is a stronger oxidizing agent. So note, we can either use manganese 4 oxide or we can use potassium manganate 7. But whenever we use potassium manganate 7, we do not heat. We do not heat because it is a stronger oxidizing agent. So the equation for the reaction whenever you use potassium manganate 7 is as follows. 2 potassium manganate 7 reacting with 16 hydrochloric acid to form 2 potassium chloride, manganese chloride, and 5 chlorine and 8 water. Chlorine can also be prepared in the laboratory by reacting bleaching powder, that is calcium hypochlorite, with dilute acids. The equation for the reaction is calcium hypochlorite plus hydrochloric acid to form calcium chloride plus water plus chlorine gas. Then finally, what is the test for chlorine gas? Given so many other gases, how would you test that a gas is chlorine gas? Now, it changes moist blue litmus paper red, then white. It changes moist blue litmus paper red, then bleaches it, and it becomes white. That is the test for chlorine gas. Now that marks the end of our lesson. Hope you've been attentive enough and you have been able to understand every point. Let us meet again in the next lesson. Cheers.
Education, education, baby. Come on, education.